good day, geometry. We are moving on to P07, where we get some more definitions about how to describe, how to define the relationships of angles. And we start with complementary angles. Have you heard of or remember what complementary angles are, what their relationship is? Jack?
Does that mean like they're like equal or like they're similar?
Vertical angles is kind of one way to describe congruent angles. Not in this case though. Complementary. You probably first learned about this in 6th grade, 5th grade maybe? Okay, so complementary angles are two angles hold up. We have a problem with the let's see. We're gonna close that. Oh, now they show up. There we go. Okay, complementary angles are two angles that sum to be 90 degrees. Okay, two angles that sum to be 90 degrees. Perhaps this triggers a memory for what supplementary angles are now. Arlene? Yes, two angles that sum to be 180 degrees. I oftentimes say, I don't know if I said this at the start of geometry or not, but basically, if you can add or subtract to 90, 180, or 360, that's like half of geometry, because there's so much that goes along with 90 degrees. Think right angles, now complementary angles. So much that go along with 180 degrees. Think the degrees in a triangle, straight angles, now supplementary angles, and 360 circles, quadrilaterals, right? There's a lot that goes into those numbers. Those are kind of the main ones here. Adjacent angles. Maybe you've heard the word adjacent before, Aiden.
Are they two angles that sum to be something less than 90?
Nope, nothing to do with their sum.
Oh.
The word adjacent, have you heard that before? Yeah.
Equal.
Not equal.
They're like on the opposite sides of.
What does the word adjacent mean? Have you had this before, a vocab word? I will give you a hint. Catherine is adjacent to Sophie. Beckman is adjacent to Olivia. They are two angles that share a side, or they're next to each other. Okay? Two angles that share a side, or in other words, they are next to each other. So an example of adjacent angles, right? The side that those two angles share would be in red there. They would be adjacent angles. Now, to have complementary or supplementary angles, the sides don't have to be adjacent. Any two angles that sum to be 90, whether they're adjacent or not, are complementary angles. Any two angles that sum to be 180, whether adjacent or not, are supplementary angles. Okay, but adjacent angles specifically are angles that share a side. Right? So I'm going to add in here, because I think I'm going to put this on one of your bell ringers. Do not have to be adjacent for complementary, and again for supplementary, do not have to be adjacent. They can be, but they don't have to be. Yeah, Catherine.
Does it have to be two?
Yes, it has to be two. Yep, three angles that sum to be 90 degrees are just nothing special. Yeah, I know, it's kind of sad, but Kylie.
Is there two angles to be complementary? Do they have to be share the same vertex?
No, they do not have to share the same vertex. So an example of complementary angles that wouldn't touch. If you have an angle here that is 30 degrees, an angle down here that's 60 degrees, those would still be complementary angles. They're not touching, they're not sharing a vertex, nothing. Okay, but because they sum to 90, because there are two of them, they would be complementary angles. Ellen. It does.
Okay, so I just can't see it.
It has nothing to do with the messiness of my handwriting.
No, it's just.
Not at all? Right, gotcha. Okay, thank you. So going down the diagram here, it says in the diagram below, the measure of angle 2 is 90 degrees, and the measure of angle 3 is 30 degrees. Remember, we can use numbers to identify angles. There's no degree symbol within the numbers here, so it's just angle 1, angle 2, angle 3, like an order. Give an example of complementary angles, supplementary angles, vertical angles, and a linear pair. So if you want to write in some angle measures, you know that 3 is 30 degrees, 2 is 90 degrees. Maybe you can fill in the rest there. What else can you do? Let's just do it together. What other angles do you know the measures for because of what's given to us? Kylie, give me one angle that you want. 5 is 90 degrees. Why? And what's that called when angles are opposite each other and congruent? Starts with a V. Vertical angles. They are vertical angles, therefore they're congruent. Good. Aiden, give me another angle.
60 degrees.
Angle 4 is 60 degrees. How do you know that?
Because angle 3 and 4 add up to be the same angle as 5 because they're linear pairs.
Okay. So we got a straight line coming through here. And so Aiden knows that 4, 5, and 3 have to add to be 180. We already know that 5 is 90. We know that 3 is 30. The only thing that's left to get that 180 straight angle would be 60. Okay, so 4 has to be 60. Christopher, give me another one. Angle 6 is 30. Vertical angles with angle 3. And one more. Damien? Angle 1 is 60 degrees because it is vertical angles with angle 4. Okay, now give me an example of complementary angles. With those angle measures marked, give me an example of complementary angles. Give me one. Ellen. 3 and 4. Angle 3 and 4 sum to be 90. That's the definition of complementary angles. Joey, you had one too?
No,
Do you see another pair?
no, I do not know. 1 and 6.
1 and 6 would work as well. Angles 1 and 6 because they add up to be 90. Another example, Claire? 4 and 6, 60, 30. Now 4 and 6 don't touch, but that's okay, right? They don't share a side. That's okay. Angle 4 and angle 6 would be another option. And Lexi? 1 and 3 also add up to be 90, so that would work too. Okay, any of those 4, they're all pairs of complementary angles. Christopher? Supplementary angles. 5 and 2. Is that the only option? It is. Okay, 2 and 5. Thank you. Yes, you can write that down exactly as I have up there. 2 and 5 are the only pair of supplementary angles because they're the only 2 angles that add to be 180 degrees. Okay, we can get 180 other ways, but for angles to be supplementary, it's only 2 of them. Vertical angles. Let's get some new people. People haven't heard from me yet today. Give me a pair of vertical angles. Sophie. 1 and 4 are vertical angles. Angle 1 and angle 4. Another pair, Max. 2 and 5. And give me a third pair, Alexis. 3 and 6 are all vertical angles. Good. And lastly, a linear pair. A linear pair. Give me a linear pair. Noah. 3, 4, and 5 do make a line. However, they're a trio of angles, not a pair. Okay, the linear pair, it has to be only 2 angles that make a line. Lexi? 2 and 5 are vertical angles. They don't make a line. They do fit the 180 part. There are 2 of them, but they do not make a line. They're vertical angles. Catherine? Joey? 2 and 6 add up to be 120. which is not 180, and so they don't make that line. Damien? 2 and 5 are vertical angles. Ellen? None of them. There is no example. There is no example of a linear pair here, because the angles that make a line, you can do it with 3 of them, but not with 2 of them. Okay, so there is no linear pair. So again, similar to CO6, we've got some diagrams here, and the point of this now is for you to look at a diagram and discover the relationship. What is the relationship that you can put together that's going to help you solve for the variable? So what do you know about the angles in that first diagram, DEG and FEG, and their relationship, so you can set up some form of an equation to solve? And what you're running through your head, okay, what do I know? Are they complementary? Do they add up to be 90? Are they supplementary? Do they add up to be 180? Are they congruent? Are they equal? Are they vertical? Are they equal? What's the relationship? Lisa? I mean, each angle equals 180? There's some. And how do you know that? Because they make a straight line. Okay? And 2 angles that make a straight line are a linear pair. Therefore, they add to be 180. So the relationship we can set up, 18x minus 9 plus 4x plus 13 equals 180. Okay? 18x minus 9 plus 4x plus 13 equals 180. And we know that because their sums, their sum has to make 180. Because the definition of a linear pair, they make a straight line. What's the measure of a straight angle, Damien? 180 degrees. Someone said, aren't they supplementary? Yes, and you know they're supplementary because they make a straight line, right? And a straight angle is 180 degrees. Okay? Vince, next one. What do you think? What relationship exists here so that we can set up an equation that's going to allow us to solve for x? Yes, you have to solve it. We're just moving on that one. Why? Okay, so then what would you set up? Well, why did you say supplementary?
Jack said it.
Okay. Okay. So Vince, what does this box in the corner mean here? 90 degrees. And you see a straight line here, line HF. So what do you know the sum of these 3 angles has to be to make that straight line? 180. We already have 90 degrees spoken for with the box, which means how many degrees are left? 90. So we know that the sum of 6x and 4x has to equal 90, because that's the number of degrees that are left to finish making the line. Okay? Like I said, geometry is all about relationships. How does one thing relate to something else? Okay? Then the last one, you've got x and y to solve for. What would you set up here? They're solving for the variable, probably.
Obviously. Oh.
Ellen. Okay, Joey? In this case, yes. It says, yeah, just solve for the variable here. Bryn, what might you set up?
Never mind.
Okay, anyone have a thought? You've got 2 variables to work with, and so what you want to avoid is setting up one equation with both variables in it. Like, you would not want to use vertical angles here and say that 2y equals x plus 5, right? Because even though that's true, 2y does equal x plus 5 because they're vertical. One equation with 2 variables, I mean, if you did go this route, we'd be looking at Oxenoy, right? PO42 from last year. We want to avoid that if possible. So what other relationship can we set up here? Ellen, try it again.
2y plus 4x minus 100 equals 3y plus 30.
Oof. That is quite the equation, and it's got double variables in it. let's just stick to one equation with one variable. Jack, what were you going to say? Okay, Christopher?
4x minus 100 plus x plus 5 equals 100.
Okay, so we see this line coming down here, and we see that line is made up of the angles 4x minus 100 and x plus 5, right? So we know that 4x minus 100 plus x plus 5 has to equal 180, because that line coming down almost vertically here, but on the right side of it, we've got these two angles that together make this line. Therefore, we know their measure has to add up to be 180. If you want to go the other side, well, you've got a linear pair here also, don't you? Right? We know that 2y plus 3y plus 30 also has to equal 180. Right? Because those two angles also make a line. So you have a couple different options here. That's why I said, geometry is very right brain. There's so many different relationships that you could come up with and potentially use. Ellen wasn't wrong in what she said. Neither was someone else who said we could go vertical angles there. It's just going to be more efficient to stick with one equation with one variable to solve for. Okay. Your homework is to finish these three, solve for the variable. We have the relationship set up. You go ahead and solve. And then the review section down here. And that is all for tomorrow. You need to solve for the variable.
Yeah, but do you need to plug in the variable?
You don't have to plug. I didn't tell you a specific angle to solve for, unless I did up at the top, which I just missed. But hold on, let me just verify. It does say find the measure of GEF for the first two. So I guess there's a little bit more that you have to do for that one. But for the third one, it's just all for X and Y. Okay, and then the 6 down at the bottom for review. Yes, Max.
Never mind.
Okay, you were so excited. What would?
You said they were gonna decide on one of these words, but they decided it wasn't gonna be that word.
Was it going to be review?
No.
Because that just would have been
Wait, is that the homework to review?
It was gonna be
It was gonna be tomorrow, and then you said tomorrow.
too easy.
I feel like that would have been fine. Yeah.
I'm almost guaranteed to say tomorrow in a given lesson.
In 22 days.
Sometimes I do. You're right. Okay, that is the class. Oh my goodness, you have 10 seconds to work on your homework. Spirit of Christmas. That's how you math.